right? So we're dealing with transformations. We're changing our function. A translation just translates. It just moves it up, down, left to left, right. You can have a reflection, which causes it to flip across. It's a mirror image. And lastly, you can have a dilation. So throw back to chapter 2 when we talked about dilation. So this can be a stretch or a compression of the graph. So dilation is a stretch. So you're stretching or you're compressing the graph. And I'll say it here on the screencast again for the people who are gone, so they know you can bring a 4-function calculator for the quiz. You just can't use the graphing one. That way you don't mess up adding, subtracting. I just don't want you to be able to graph not calculate and copy it over. All right, there's 2 types of dilation, right? So there's vertical, where you could say it's stretched. Vertical stretch. And vertical compressed. These are the ones we're going to be focusing on. Vertical stretched and vertical compressed. So we're going to graph these equations. We don't really need our calculator because we already know what it's going to look like. So 1/3 x squared. So ready? It's all time. It's time to like move your body. Ready? So on the count of 3, we're going to see what does x squared look like. All right, ready? 1, 2, 3. What's x squared look like? A U shape. Ready? What is 1/3 x squared? Widens it out. What would 3x squared look like? Right, so you're multiplying every number by 3, so you are stretching it, and which causes it to look more skinny. So if you're multiplying by a number greater than 1, it gets skinnier. If you're multiplying by a number less than 1, it's going to get wider, because you're literally taking all the y values and halving them. So instead of having your U shape here, it's going to widen it out. So instead of having a nice U shape, it's going to cause it to be more wide. Okay. We learned about this in chapter 2 when we talked about transformations of general functions. We learned about absolute value. So an absolute value, that was a v. If you have a number, remember how we like had the change of slope? So 2 times absolute value was much skinnier than 1/2 absolute value, stretches it, like pushes it down. Yeah? Remember? Like a month ago? Yeah, like 1 month ago. Okay, so I'm going to graph the parent function first, just a little review. So x squared, oh my gosh. Do we remember the coordinates? What did we use for our x values? -2, -1, 0, 1, 2. And then, can you square these with a calculator? What's -2 squared? 4. -1 squared? 1. -0 squared? 0. 1 squared? 1. 2 squared? 4. Cool. So I'm going to graph my parent function. What does a parent function mean? What's parent function mean? Yeah, it's just the general, just the x squared. That's it, just the parabola, just x squared. That's the parent function. So I'm going to put these points on my graph. And this is y equals x squared. Now, I want to go through, and here I should be graphing 1/3 x squared. So what this literally does is it multiplies all of my y values by 1/3. So I'm going through and I'm going to multiply all of my y values by 1/3. So this doesn't have to be too hard. 1/3 times 4 is literally going to be 4/3. How big is that? 4/3. Can I write this as a mixed number? 4/3 is the same as 1 and 1/3. How many times can 3 go into 4? Once. How many remainder? 1. So this is the same as 1 1/3. So if I go over to graph it, I'm going to be graphing -2, 1 1/3. Okay, so what does this even look like? So I go to -2, and then I go up 1, and about 1/3 of the way. 1/3 of the way up.
Where should this be? Oh. Yeah. I don't understand where you got the numbers from though for the x.
So the x squared, it's the general parabola, it's the parent function. So if I plug in -2 into x squared, I get 4. -2 squared is 4.
But where do you get -2?
So those are the 5 points we selected at the beginning of 4.7 for our parent function. These are always gonna be the 4 you start with.
Be -2, -1, 0, 1, 2.
For when we're graphing transformations. All right, so 1/3 times 1 is just going to be a third. Oh my gosh. So I have to go to -1 comma a third. So I go to -1 and about a third of the way up. So I'm doing it in 2 different colors so you can see what's happening. Let's see. 0 times a third is still going to be 0. 1 times a third. Oh, we already have done these. This is a third. This is 1 1/3. So as you can see, this is going to be a lot. This is widening out, right? You see how my original parent function, multiplied by a number smaller than 1, it widens out. So this vertex, since the only thing I did was dilate it, I have the same vertex.
And you did it because it's less than 1.
Because it's less than 1. What do you think is going to happen if I have 3x squared? I have my parent function, it's going to get skinnier. Because it's bigger than 1. Because the coefficient, the number in front of x squared, is bigger than 1.
Wait, so I'm still a little bit confused. So for the y part, so I understand that it's always going to be -2, -1, 0, 1, and 2 for x, right?
Yeah.
On the left. But for y, will it
So the
always
blue
be
ones were our
y?
parent function, and then so I had plugged in my x values, squared them to get the blue numbers, right?
Oh, so it's just -2 to the second.
-2 to the second, yeah. -2 times -2 is just 4.
How are we gonna graph 12?
So whatever is
12?
next to the second is literally just multiplied by whatever is in front of x. That makes no sense.
That's fine. Okay.
Can you just go off the graph?
Ish. We're gonna try to graph the numbers that we can. So we'll go through. I'm gonna list out my original functions, original coordinates. Come on. Okay. Oh my gosh. Why is it so slow? So guess what I'm gonna be writing? -2, -1, 0, 1, 2. We start with these numbers when we're dealing with transformations, and then all these things squared. Let's see, 4, 1, 0, 1, 4. And I have to go through and I'm going to multiply every number now by 3. So I go through, multiply each of these by 3. Okay, so first I'm going to just graph the parent functions, the blue coordinates, right? 0, 0, 1, 1, 2, 4, I'm graphing my regular parabola, so I can graph the other parabola on the same grid to show you what's happening. So on your quiz you don't have to do 2. But I'm having you guys practice the general parabola because I want you to understand at a base level, understand what is going on here.
So then it would be -2 and 12.
So, right, so I'm going to do -1 comma 3 and 1 comma 3. 2 comma 12, so that's about right, like, up here. So you see how this is going to be hard. Oh my god, I selected it. I mean, I was just graphing all 5 points because I know that one's for sure on my grid here. So are we surprised that it's getting skinnier? No, because we talked about it already. So from the blue to the green, it's getting skinnier. Okay, so I'm going to write like what's happening. So for the left side, the words we want to use is vertically compressed. So with the pink one, it's being vertically compressed. So I'm being as specific as possible. We're only going to deal with the vertical right now. AKA, it's getting wider. With the green one on my right side, you see it's getting vertically stretched. It's kind of like you played tug of war, and now you're stretching the green one out. Vertically stretched. So this is, we say it's getting thinner.
Is that also 2?
Yeah, negative 2, 12, and 2, 12. All right, now some fun. Without graphing, describe how each graph is related to the parent graph, f of x equals x squared. So if it's getting vertically compressed, ready? Think about it. Vertically is up and down. If you're compressing it, it's getting wider. If you're stretching it, right, it's going to get a lot thinner.
Oh, right.
I don't know if the hand motions help. Okay. So without graphing, describe how each graph is related to the parent. What? Vertically stretched. Yeah. Vertically stretched. Imagine that like someone's pulling my arms up, being stretched. Right? So you're like a parabola here and you're being stretched, it's being pulled up. So it's getting
Is there like
thinner.
horizontal spread?
Well, there is, but I'm trying to be as specific as possible. And we're only going to talk about the vertically compressed and vertically stretched, just so we all have the same way of talking about it. Okay, so without graphing, describe how it's related. Okay, so first, I see the negative. That's going to be a reflection. Reflection, so it's going to be, it faces down.
Wait, so if there's a negative
in front of x squared, The 2 right? This is bigger than 1, so I'm going to have a dilation.
Thank you.
Oh yeah, so I'm going to, you're what? It's fine. Some screencasting so that way you don't, whatever you miss will be on here. All right, so dilation, so I see the 2. Okay, so number bigger than 1. What's happening? It's getting thinner. And wait, if it's being thinner, it's being
Vertically stretched.
vertically stretched.
Oh, right.
I'm just trying to like color code so you see like I'm taking account every single thing. And then lastly, what does this negative 3 do? It's a translation and it moves vertical down by 3. Wonderful. Okay, take a second. Try out part B yourself, right? Try the second one. See if you can get what the translation would be.
Is this stuff going to be on the test?
So reflective.
Yes.
Is there always all 3 of those?
Not necessarily.
I mean,
Imagine I didn't have the negative 3. Like, notice I didn't have a horizontal translation.
Is there always
Translation is you're not like changing it, you're just shifting it. Versus the dilations, you're literally changing the
is
thickness.
there always gonna are you always gonna have a translation?
No. So notice these two, I didn't have a translation. I didn't move them. All I did was stretch the graph. Yeah. It's a good bet though on the quiz. I'll give you a translation in it.
Translation only when it's negative.
No, so the reflection's only if it's a negative. The translation is if you're moving side to side or up and down. So do I have a reflection for the second one? I don't. No reflection.
Oh, so
How do you know that it's
But there's a square in it.
So that's a translation, not a reflection. Reflection is a mirror image. It flips it across the axes.
yeah, but it's
So if it was positive 3, it would be
Then it would be up 3 for translation.
so there's no side. I thought
There was no side for A, side to side. Okay, so all right.
Make the translation for the second one be up 1.
So translation, we're going up by 1, and so we have a vertical translation and a horizontal, and what? Which way are we going?
Level 2.
Left by 2.
when wouldn't there be translation?
So if I just had like 4x squared,
Oh, if there's no
if there's another number inside, like x plus or minus a number, that's gonna be a horizontal. If it's literally gonna be x squared plus or minus a number, whatever's out here is gonna be vertical. Okay, so I have translation, and what's this 4 in front doing? Dilation.
Wait, why are we doing translation first?
Well, that was what we were talking. Well, he just selected it. He was asking about it first. I think, was it Eli, maybe? Like, shouted it out. We could have done dilation first. It didn't matter. I'm just trying to take into account all the changes that's happening. Yeah. if you wrote, like, the order you wrote it, not as important as you actually recognizing that it is a movement. All right, so dilation, the 4, what does the 4 do?
Moves it.
Vertically stretches it by a factor of 4.
Would you also put like the four, like that equation or whatever into like simplified form, so it's like 4x to the 7 plus 65? No.
It wouldn't be plus 60. I mean, so this is in vertex form, which is one of the next things we're going to talk about, which is actually the next thing we're talking about. So this is called vertex form.
Was there a reflection?
Wait, what? No, there's not a negative in front. No reflection. If it was -4, the negative in front would reflect it. Here it's facing upward, no reflection. Okay, so this is called vertex form. This is not the first time we saw it. I introduced this to you in chapter 2. The vertex is literally going to be h, comma, k. Right? H, this is your horizontal, k is your vertical. So that's what this page is talking about. H is your horizontal translation. If h is less than 1, then it's going to be going to the left. If h is greater than 1, it's going to the right. But imagine, if you plug in a positive number for h, it would be x minus that number. All right, so what I'm talking about here is if you plug in a positive number for h, you would have x minus whatever number you plugged in. So if I plug in 2, 2 is positive. So I have x minus 2. And wait, minus 2, inside it goes off the way you think, so it would be going to the right. If I plugged in a negative number, like -1, if I plug in a -1, you have x minus a negative. Oh, that's why if it's positive inside, it's going to the left. It's always opposite of what you think. Okay, k is your vertical translation. It's literally the part that's tacked on the end. It's just added or subtracted at the end. Notice the h is inside the parentheses, inside the absolute value, inside the root, like inside of the where the square is talking about. So k is not affected by the squared. K is your vertical. If you have a positive k, you're shifting it up. If you have a negative k, you're shifting it down. If you don't have anything that you're adding, guess what? It doesn't move up or down at all. So this is just a different way to talk about what we've been doing. A is your reflection, literally the number in front of it, right? The coefficient, if it's positive, it'll face up. If it's negative, it faces down. And then a dilation. So if it is greater than 1, it's going to be stretched vertically. We just talked about this, right? If you have a number greater than 1, you're stretching it vertically and it's getting thinner. If you have a number less than 1, right? Less than 1, you're being pulled to the sides. You're being pushed down. It's being vertically compressed. It's just a summary of what we've been doing with some examples. Okay, graph the parent function, then use the transformations to graph the function. I'm going to do this one on page 15 first because there's a question just like it on the quiz. And then we'll go back and we'll do the other 4 problems. Because those are a lot like the problems that you'll have on the quiz as well. Okay, to determine the equation of a function based on its graph, it's possible to use the vertex and a point on the parabola. So what you do, we want it in vertex form. Well, vertex form is y equals a times x minus h squared plus k.
Are you giving us a formula?
Did I give it to you on your quiz? Your practice quiz?
No.
I'll write it on the board.
You have one of them.
I did?
Yeah, you have
No,
for
it's not.
1 through 4 consider the factor of x.
That's not the general form though.
Yeah.
So I'll write ax squared plus bx plus c equals 0. I'll write y equals a times, I'll write the vertex. I'm not going to tell you it's vertex form, but this is vertex form. So we know our vertex. What's our vertex?
3, 2.
Yeah, the vertex is where you have your maximum or minimum. So here our vertex is at 3 and 2. So this means h is 3, k is 2. And all I have to have is one other point to plug in for y and x, so I can solve it and put it in vertex form.
Well, what about?
I have to solve for a. So I have this other point, -1, -2.
But that's not where it intersects with the y.
It's not at all, but it is a point that was given to us.
So the x,
So I'm given a point, and I'm given the vertex. If I plug in, I can solve for A and then write the general vertex form.
So we don't have to just choose a random point. You'll give us both points, right?
Look at the last example on the quiz, practice quiz. Did I give you a point? Then did I give you the vertex?
so the vertex is the h and k, right?
Yes.
And then just the x.
And then you have your second point. So on the practice quiz, in the last question, did I give you... I literally say, write an equation vertex form for a parabola with vertex -1, -7, and passes through 0, -6. There's a problem just like this on your quiz. So we're walking through how to do this. So I'm going to plug in all of these numbers. What is wrong? Okay. What?
No.
Okay. So I plug in for my A, I plug in for my Y, my X was -1, my H was 3 squared plus K, which was 2. -2 equals A. -1 minus 3 is -4. Squared plus 2.
First, like when we do
No, it parentheses. Parentheses, exponents. You have to do the parentheses first before you can do the exponent.
no, I
Is
know.
the h always the first?
H is always the X of your vertex. K is the Y of your vertex.
But when we do a times -1 and then a times.
No, you have to do the stuff in the parentheses before you can multiply A out. You have to follow the order of operations. Please excuse my dear Aunt Sally. So P, please do the stuff inside the parentheses. Then I can do the exponent. Then I can multiply A by it. But I have to go in the right order. You have to do the stuff in the parentheses before you can do the exponent that's acting on the parentheses. Before, right, and the last thing you could do is then multiply it by A. So I have -2 equals A times what is -4 squared? 16 plus 2, so I'm going to subtract 2 from both sides. Hello, so I have -4 equals A times 16. Last thing I need to do solve for A. Divide by 16. What is -4 over 16? Can I simplify this?
Yes, and -1
-1/4. So then I have A, H, and K, and I can just plug it in.
So then is it
So-
just asking what a is?
Nope, I'm wanting the equation in vertex form. So I have to write the equation in vertex form. In order to do that, I have to solve for A. So I have Y equals -1/4 X minus 3
How did you get -1/4?
squared plus 2. This is the answer. All right, how did I get what?
Oh, so you just put it back in the
Yeah.
original.
Yep, because I'm wanting an equation in vertex form.
And then
So-
4 going to 16.
Yeah, it does. So -4/16 is the same as -1/4.
Why did you put that x?
Because I wanted an equation, not a number.
okay, not it.
So I used the x and the y because I know it's on my parabola to solve for A. All right. So, what do you mean?
Like when you got your final answer.
Yeah. So literally, I give you H and K. You plug it straight into your vertex form. I had to solve for what this A was. That's all the work we did was just to solve for the A. I'm sorry. You bleeding? Are you okay?
What? No.
Just concerned. Yeah, make sure your phone stays here. All right. So, do we have questions about this process? There's one on the practice quiz. There'll be one just like this on the quiz. It's just instead of writing, like showing the graph, I literally tell you, this is the vertex, this is the other form. And I will write this general one on the board for you. Cool. We'll probably have like 10 minutes being in class to like do a little more review during F. So if that helps you a little bit. You can work on Alex now. I just want to make sure everyone has enough time. So if you have extended time, like it'll be done during class. Okay, so let's go back up. And these are more what This is similar to what I would have you do. As far as vertex. So it says use the transformations to graph the function. If you're looking at the practice quiz, well, we'll do A and B and then I can go through the practice quiz. Okay, sixth. Let's see, you were doing ACT, right, Lauren?
Yeah.
Okay.
I think I have the ACT on a school day.
I don't know. Okay. So, graph the parent function, then use transformations to graph the function. Okay, what is the transformation? Yes?
My fingers actually feel a little bit.
Go to the office. Get a Band-Aid. All right, what is the transformation here?
-5.
So, down 5, right? I'm going down by 5. Down 5, right by 2. Wait, what this told me is, guess what? That's where my vertex is. I go to the right by 2 and down by 5.
Why did you go to the right by 2 though?
Because it's x minus 2, and inside is horizontal, and you always do the opposite
It
way.
was x plus 2.
You'd go left by 2. So if that's my vertex, I'm going to act like this is my general xy. All right, so let's see. What were my indexes? Let's say -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. Okay, those are like my xy coordinates that we always use. So I could plug in, but this is a way to do it without like having to do lots of math. Without having to like plug in and find all that. So what this shows me is this is always my vertex, is always the middle one. So if I go to the left of it by 1, I'll have to go up by 1. So you go left 1, up 1. If I go to the left of my vertex by 2, I have to go up by 4. Left 2, up by 1, 2, 3, 4. And then since I know my vertex is where my line of symmetry occurs, since I am over 1 and up 1 from my vertice, I also will be over 1, up 1 on the other side because there's a line of symmetry.
I'm so confused because I graphed this, but how are you putting it into?
So this is one way of doing it. You understand that my vertex moved, and that's where my axis of symmetry is. And then judging by our xy coordinates, you say, okay, going from 0 to -1 is a change of 1 in my x. So if I go left of my vertex by 1, I go 4 up from where my vertex was. So I go 1.
Where did you get 4 from?
-2, 4. This is my points.
But I thought we were doing -1.
Yeah. Okay, let me redo this and show you how I. Let me slow down for a sec. Okay. Okay.
Like, couldn't you just graph
Just a
it
second.
open, like,
Just a
so, like,
second.
92, 4?
So, let me redraw this x, y. Here are my points. Let's see, 4, 1, 0, 1, 4. So I said that I'm going to the right by 2. So I'm literally going to be adding 2 to all of my x coordinates. And I said I'm going down 5, so I subtract 5 from all of my y coordinates.
Wait, so why are you adding 2 instead of subtracting?
Because I'm going to the right by 2. So all of my x's are now shifting to the right by 2. So I'm adding 2. What used to be at 0, 0 is now at 2. What used to be an x of 0 is now an x of 2. 1, 2, 3, 4. -1, -4, -5, -4, -1. So this is how we did it.
So basically all that
and
you
the-
have to graph is just
So I found my new points. 0, -1, 1, -4. I shifted all of my x coordinates right by 2 by adding. I shifted all my y coordinates down by 5 by subtracting 5. Just give me a second. Okay. So for this graph, how many solutions does it have? So solutions is number of times it touches the x-axis. How many times does it touch the x-axis? Twice. It touches the x-axis twice. 2 times. It has 2 solutions. If I would come up here to, let's see. Oh no, I forgot I didn't have these notes filled out again. If I would have a graph where it doesn't touch the x-axis at all, how many solutions would that be? 0. It doesn't touch the x-axis at all, so it's 0 solutions. The number of solutions is just the number of times it touches the x-axis. What about if I had it touch at just 1 point? Just right here. That's all it touches. How many solutions would it be? 1. So number of solutions is just the number of times it touches the x-axis. It could touch it 2 times, 1 time, or 0 times. Those are your only options.
Left one.
What?
Wait, are you still on the first one?
Yeah, I'm still on the first one.
Wait, do you want us to go through the function?
You know, on the quiz, I don't have you do that, so it's fine. All right, let's try B. So what is the translation? What is the change? It flips, it goes left by 1, and it goes up by 4. So I'm going to write out my coordinates. And so when you use the transformation, it's like number 5 on your practice quiz. If you look at number 5 on your practice quiz, all I'm doing is I'm just going to change the numbers. This practice quiz is going to be your quiz. I'm just changing numbers. There you go. I'm telling you right now. So number 5, it's in vertex form. So what you can do is the way we're graphing it. Versus number, I think it's like number 3 here is exactly how we were doing it in 4.1. Where you would find the axis symmetry and then you pick the numbers that are around it.
Can you give us the vertex form?
What?
Like you said, you were gonna give us.
I'm going to write it on the board when you have your quiz.
What is it?
The vertex form, it's on the previous page. It's on page 13, top of page 13.
That x equals ax minus h2 plus k.
Squared plus k.
So it's like the opposite for this.
So the horizontal is always opposite. So here, since I have an x plus 1, inside the parentheses means horizontal, and it's always opposite what you think. So you'd think plus 1 would be going positive, but it's not. It's going opposite way.
Is that all the time? Or?
Yeah, for horizontal it is. But here it's a plus 4, and that's going up. Right, so only horizontal, it's opposite what you think. All right, what do we have like 5 minutes left of class. Do you need to really bad, or is it okay? I mean, you can if you need to, but I'm doing this problem. Okay, so I'm going left by 1, so I'm going to subtract 1 from all of my x values. And you kind of have to follow the order of operations. What's wrong? Is there what? Yes, there's a different schedule because you guys get out at 2:10. Because we have a faculty meeting for an hour about culture. Yep. Okay, so notice after I square the x, then I'm flipping it to make it negative. So I have to go through and change all the signs here. And then after I do that is when I go and add 4. Because remember, this right here is what x squared is equal to. And you have to make it negative from right there.
Wait, can you just do like what the first step was over there? It's like you go up 4. So you go up 4.
But you can't, if you add 4 first and then flip it, it's wrong.
Wait, so
You have to flip it and then shift it up and down.
for these ones, you do it with the x's, right? Like you add or subtract. Before we do the one.
So I added 4 since it's up 4, that's vertical, that's why. But going left by 1, left is horizontal. So that's when I subtracted 1. I'm here bonus every day.
On the other ones, we didn't do that. Right?
Well, I didn't have to flip it over here. But notice I had 2 changes I had to do, horizontal and vertical.
Didn't we just square it every time? The x's?
I already have my x squared. It's right here.
But the negative.
Yeah, so I put the negative in front
Because of that.
because of it being flipped right here. That's why I put the negative in front, and then once I make a negative, then I add 4. So I'll be here at bonus. The math center is open tomorrow 10 a.m. to 2. So you have to flip it before you can shift it up. That's why I put the negative here first. I multiply by -1 everywhere, and then I shifted it up.
If you flip it, isn't it positive? Because it's a negative already.
What?
Isn't
What do you mean it's
when
negative
the
already?
circle flips,
Yes.
it's a negative.
That's what this right here is for. It's for flipping it. This is for flipping it. I don't know what you're asking me. I'm trying.
Because before we never did the
Because
x's.
I didn't have you do the flip before. Before, we were only shifting a vertical.
Wait, hold up, I didn't.
How are we gonna know which one to do?
If it has a negative in front or not. If it does have a negative in front, you don't have the negative and you just add or subtract your vertical shift. If it has negative in front, you have to multiply by negative before you shift it up and down. So if I would plot it, I have -3, 0, -2, 3, -1, 4, 0, 3, and 1, 0. So,
Can I show you what I did? Because I did that
sure.
the first time. Like I did it. Okay, so I did something the first time.
This is what it should look like.
Yeah. So
Okay.
remember how we did the other one where it was like the negative 5, so you'd be going down 5.
Yep.
And then the -2, so you'd be going right 2. So I just kind of did that for the other one. So +4, so you'd go
Yes.
like left 1 and up 4.
Left 1, up
And-
4.
And then I just like.
So you literally shifted all of them.
Yeah, I just
with-
shifted
yeah,
it in the beginning.
this is the same thing.
Same thing. Just did.
Let me look. Okay, so you guys can pack up. Let me see what you did.
I just did like left 1 and then up 4 and then just went like did X, Y, and I think first was like okay, and then it goes -2.
So flipping it, so you have to flip it first, right? So you have
Yeah.
like -1, then +4 would be 3. Yeah, as long as you have to do the right order. Because imagine if you made it negative after the fact, it would be 0, -3,
Yeah.
-4, right?
I just
All
tried
right,
everything.
I'll see you guys Friday. This is tuitions are online. Come to bonus if you need help. Cool.